instead of a system of equations. So we already graphed equations, we solved equations. Now we're going to look at them as being inequalities. So what is different with an inequality versus an equation? How would the graph differ? Jillian?
Would like whole parts of the graph be like shaded instead of just like points?
Exactly. So with a system of linear inequalities, we're not looking for where they cross, but we're looking for where like the system has a solution, which would be a shaded area. So a system is just graphing two or more inequalities. And then a solution of a system would be where the shaded region overlaps. So instead of where the lines overlap, where the lines intersect, we'll now be looking at where the shaded region where that overlaps. Or you could say intersects. So a system is two or more. It doesn't just have to be two. So we could have multiple lines being graphed. The solution would be wherever that shaded area is going to overlap. So you'll be shading for multiple lines. We're going to be looking for that overlap of the multiple lines where they were shaded. The graph of a system is just the region of the graph wherever it exists. So wherever it's defined is called the graph of the system. And it might be a certain shape. It could be a triangle, it could be a quadrilateral, it could just be like an open area bounded by our lines. So sometimes it actually is a shape if it gets enclosed by a couple of lines. So there's a couple little fill-in blanks underneath. To graph a system, it says graph each inequality in the system. You may want to use colored pencils to distinguish the different regions or shaded areas. So if you have colored pencils, if you have colored, if you have crayons, pens, if you want to get those out, you can. I just tend to shade like different directions so that I can see my difference. You'll just need two today. So if you have a pencil and a pen, like that even works. One pencil, one pen, that's all you need for today. And then it says, identify the region that is the same to all of the graphs, overlapping with all of the graphs. This region of the graph, this region is the graph of the system. So that overlapping region is the graph of the system. If you use colored pencils, the graph of the system is where there is the region that has been shaded with all of the colors, or every color. So if you have a pen and a pencil, you're looking for where that pen and pencil are overlapping. If you have a red pencil and a green pencil, you're looking for where there's two. We're just using two. So again, if you don't have colored pencils, it's okay. If you have a pen and a pencil, that's fine, or a black and a blue pen, whatever. You don't have to use multiple colors either. So I just tend to shade in different directions so I can see my overlap. So looking at the first question, we have y is less than 2x plus 1, y is less than or equal to negative x minus 3. Starting off pretty straightforward here. You don't have to solve for y. There's no getting y by itself. The equation's already in y equals 4. So we want to graph both of these lines. We're going to shade each of them and determine then where they intersect. So the intersecting area would be then the solution of the graph. So graph the first one, starts up at 1, and we go up 2 over 1 or down 2 backwards 1. So a inequality is different because it involves shading. What else is different when you connect the line? Holly, do you remember? Oh, I went down one too many. There we go. Thanks. Do you know what we do when we connect this line if it says y is less than 2x plus 1? It is below the line. So when we shade, we have to shade below the line because it says less than. What else do you have to do when you connect the line? Emma? Yeah, it's a dotted line. So you need to look, not only does it say less than or greater than, but is it less than or equal to or greater than or equal to or just less than? So this one is just less than. When you connect your line, you need to connect it with a dotted line. Because that means the solution is not on the line, but it's everything below the line. So make sure you're looking at the type of inequality and deciding, does it make a solid line or a dotted line? So less than, greater than would be a dotted or a dashed line. And then Holly did say below. So always think either above or below the line, never left or right, unless it's a vertical line. So go to any of those points and just go below the line. So we have our first line graphed here. See if you can graph the second one. With the second one, make sure when you connect them, you make a solid line. And then again, it does say less than or equal to. So less than or equal to means we're still graphing below the line. My smart notebook crashed, so hopefully you have a beautiful picture. So we have this dashed line, we shaded. This one is a solid line, also shading. And then make sure you darken the overlapping region. So if you're using colored pencils, it would be where the two colors are intersecting with each other. If you shade it in different ways, like I shaded vertical and then like left and right, so it would be where my shading is overlapping. Make sure you darken that area. So the solution is this little section down below. Make sure you emphasize where that solution is. Don't just leave both colors there. So it says identify the region that is common to both, the same for both, whatever you want to say there. But by identifying that region, that just means to darken that area. So you're graphing both of them, you're shading, and then darkening the solution. So if you flip the page, number 2 is pretty much the same, except that we have to solve the second inequality to get y by itself. So the first one is already in y equals form. We have y is less than or equal to negative 3/4 x plus 1. So you can graph that like normal. Less than or equal to means solid line. And again, less than is below. So we would be shading below the line. So you'll have to remember, think above versus below. Less than or equal to, below the line. Greater than or equal to, above the line. The second one, we have 3x plus 4y is greater than 16. Connor, what would you do to get y by itself in that equation?
Subtract 3x.
So take the 3x to the other side. And then,
Divide by 4.
yeah. When do you have to flip the sign, Connor? Anybody?
If you're dividing by negative.
Yes, exactly. So remember, when you're looking at inequalities, we solved them in chapter 1. If you divide by a negative, you have to flip the sign. Only when you're dividing by a negative or multiplying by a negative, not just because you're dividing. So if you're dividing by a positive 4, the sign stays as a greater than sign. So the second equation, y is greater than negative 3/4 x plus 4. So this one starts up at 4. And then we're going down 3 to the right 4. So graphing this is greater than, so that means greater than is a dashed line. I think that's one of the common mistakes, to not really look to see what kind of line you're creating, whether it's solid or dotted, solid or dashed, and just to always connect them to be solid. And then greater than means we want to shade which direction? Above it. So we would be shading above the line. So what's the solution then? Vishal, what's the solution? There is no solution. Because there's no intersecting, overlapping area. They don't have any space in common. Because one's shaded above, the other one's below, so they'll never connect with each other. So there would be no solution. If our inequality symbols were flipped and they were both shading in between, then you would have a solution that would be shaded in between. Questions? So the two down below look a little more interesting because we have some absolute value symbols in here. Again, pretty much you have y already by itself, so not a lot of solving that you need to do. But the first one is just a y. We have y is less than or equal to 3. Gavin, when you just have y, what kind of line do you get when it's just y? Horizontal, yeah. So this is going to make a horizontal line. Because it's just y is less than or equal to 3. There really is no slope. So you're going up to 3, making a horizontal line that is solid because it says less than or equal to. So we have a solid horizontal line. Less than means below. So there's a pretty big space down here that's below the line. All right, the next one. We've got these absolute value bars in the graph. Where is the vertex of the absolute value graph? So what is the vertex of this graph? Y is greater than the absolute value of x plus 4. Meaning, what direction does this graph move? What's that +4 do to the graph? How does it shift it? Connor?
It shifts it to the left.
Yeah, so this graph is moving left 4. That means the vertex is going to be at -4. Connor, does the graph move up or down at all? Is there a number being added or subtracted back here? No. So the graph is not moving up or down, so the vertex will be at -4, 0. So you're shifting left 4, but not moving up or down because there's nothing being added or subtracted outside of the absolute value. So you have a point on the x-axis at -4. What shape is this graph if it's absolute value? Abby? Yeah, it's a V shape. And whatever number's in front is the slope or the A value, and that's a 1. So that means we're going to go up 1 and right 1, up 1 and left 1. That gets the V shape. So you're going up 1, but then you're moving left and right in both directions. So up 1, right 1, up 1, left 1. So you should have a V here. Absolute value makes a V. When you connect, it just says greater than. Make sure you have a dashed or a dotted line when you're connecting this. And then you're shading above the V, which means you're inside the V. So above the V would be inside the V, greater than the V. And then darken that region that's below the line and inside our V. So this one makes a triangle. It's a bounded shape. So see if you can graph the last one there. We have y is less than or equal to 1/2 times the absolute value of x plus 2. So think, how does the graph shift? That 1/2 is your slope. So you're going up 1, right 2, up 1, left 2. When it's x, it should be a vertical line. So the graph shifts to the left 2. The slope is 1/2, so up and left or right. Up 1, left 2, up 1, right 2. This is solid. And less than means below the V. The second one is that x is greater than or equal to -2, so that's at that V. Greater than or equal to is another solid line, vertical. And when you have a vertical line, greater than is to the right. So at the V, you're looking at the diagonal line and then the vertical line that's creating your overlapping region. So you're at like that vertex area. You have the right half of our V. So the homework for today is to do some graphing. So 8 to 15 in your book, 34, and then 41 to 47 odd. Assignment sheet was sent to Remind, posted to the Google Classroom, and then the assignment is also written on the board back there. Have an awesome day.